4.5 continued again. Let's look at number 20. So find a general solution to this equation, y double prime of theta plus 4y of theta, excuse me, equals sine theta minus cosine theta. Okay, so the auxiliary equation, of course, is just r squared plus 4 because there's no y prime term. This time it gives us r is plus or minus 2i. So in the alpha plus beta I form, alpha is 0, beta is 2. Therefore, your homogeneous case is c1 cosine 2 theta, c2 sine 2 theta, this being the 2. All right, so now I'll apply the method of undetermined coefficients to find the particular solution. And so the form you would get is theta to the s, and then here's your undetermined coefficient form. Okay, then you got to figure out s. So this is where I wrote more stuff down. So since r is equal to I, is not a root of the auxiliary equation, s is equal to 0. S is equal to 0. So that gives you a 1 there. So we have y particular equal to a naught cosine theta plus b naught sine theta. When you take their derivatives, you get y prime particular is b naught cosine theta minus a naught sine theta. Y double prime particular, it's all cyclical, of course, but we're not going to come back to the original, but it is cyclical. Negative a naught cosine theta minus b naught sine theta. All right, so now I'll substitute into the given. That's why I had that little star there. So substitute back to here. And you have y double prime particular plus 4y prime equal to, this is a little long, I think I can fit everything there, minus a naught cosine theta minus b naught sine theta plus 4 times a naught cosine theta plus b naught sine theta. Simplify that a bit, and you get 3a naught cosine theta plus 3b naught sine theta equal to, so now we're setting it equal to the right hand side. So sine theta minus cosine theta, and we can equate coefficients. So that implies then that a naught is equal to negative 1/3 and b naught is equal to 1/3. Substitute back, y particular of theta is sine theta minus cosine theta all over 3. Now combine the particular and the general and the homogeneous. So now combine, and you have y of theta equal to sine theta minus cosine theta all over 3 plus C1 cosine 2 theta plus C2 sine 2 theta. Okay. So last one. This is example number 28. This one, so this is an initial value question, and everything is very similar. So we're just going to copy it over as so you have seen. So this one is a good place to try it. And then we'll check it out. So find the solution to the initial value problem. So y double prime plus y prime minus 12y equal to e to the t plus e to the 2t minus 1. And it's given that y of 0 is 1, y prime of 0 is 3. Okay, so we have our auxiliary equation is r squared plus r minus 12, which is equal to 0. And we factor that, of course. And we get r plus 4, r minus 3 equal to 0. If and only if r is equal to negative 4 or r is equal to 3. All right, so y homogeneous of t is then, just like before, c1 e to the negative 4t plus c2 e to the 3t. Okay, so now let's find the particular case using undetermined coefficients again. All right. So y particular is equal to a naught e to the t plus b naught e to the 2t plus c naught. To take its derivative, you get a naught e to the t plus 2b naught e to the t plus 0, right? Second derivative, y double prime, is, let's come back over here. So now y double prime, p, is a naught e to the t plus 4 b naught e to the 2t. Okay, so now we can substitute back and then equate just like we would do. So y double prime of p plus y prime of p minus 12y of p is equal to negative 10 a naught e to the t minus 6 b naught e to the 2t minus 12 c naught. So that's equal to the right-hand side, e to the t plus e to the 2t minus 1. Okay, so now equate coefficients and solve. So you're taking this form, right? That's your given, and this was your undetermined coefficients, and then you took the first prime, second prime, right? I mean, plug them back in, and then now you get this. Now you're setting it equal to the right-hand side. Now you want your coefficients to be equal. So now you got to solve that. And then find C1 and C2 by using the initial conditions. Okay, so we got a little bit of things to do here. But we get A naught is then negative 1/10. B naught is negative 1/6. And C naught is 1/12. Okay, the general is y of t, negative 1/10 e to the t, minus 1/6 e to the 2t, plus 1/12, plus c1 e to the negative 4t, plus c2 e to the 3t. And so that's now what we want to solve for, or C2 and C1. Find those using our initial conditions. So find C1 and C2 using the given. So y of 0 is equal to 1, y prime of 0 is equal to 3. So those are our initial conditions. So we got to do y prime of that whole thing now, because that's how we'll find our initial conditions. So y prime of t, well, that first one's always the same, huh? So negative 1/10 e to the t, minus 1/3 e to the 2t, minus 4c1 e to the negative 4t, plus 3c2 e to the 3t. So then we have 1 is equal to y of 0, which is equal to, now substitute in, so it's negative 1/10, substitute in 0, and you get these coefficients because that's raised to the e. Okay, so you get 1 equal to negative 1/10, negative 1/6, plus 1/12, plus c1 plus c2. And then you get, similarly, 3 equal to y prime of 0 equal to negative 1/10 again, but then you get negative 1/3, negative 4c1 plus 3c2. Okay, so now you're solving the system. C1 plus C2 equal to 71/60. You just got to add all that up. And negative 4C1 plus 3C2 equal to 103/30. You can do that in calculator or whatever. And then you solve. So solve the system. You could multiply by 4 if you wanted to, like that, and then add, and then cancel it out. Anyway, probably elimination would be the easiest way to do it. So I get C1 is 1/60, C2 is 7/6. Therefore, the solution is, the particular solution for this question is negative 1/10 e to the t minus 1/6 e to the 2t plus 1/12 plus 1/60 e to the negative 4t plus 7/6 e to the 3t. Okay. So putting together a couple different situations previous sections on this superposition principle, but just kind of know how to smash them together to add them up. That's the concept, more general concept. Okay, and then next we'll go on to 4.6, variation of parameters. This is a more general method that we'll develop. Take a little bit of time on that one. And then lastly, 4.7 will be variable coefficients and equations, and we'll only look at a special case of that.